Alright, we are studying relative extrema. This is the function that we're going to be looking at in this next problem here. And I went ahead and graphed it out, and looking at the graph here at Google Graph. The Google Graph. Anyway, so as you can see here, there's going to be a minimum that's going to occur right here. It looks like at 0, 0. And there's going to be a relative max, also sometimes known as a local max and a local min. Anyway, so we got a local max. Looks like it's occurring at 2, I guess 2, 4, and then 0, 0, right? And you can see that the function is decreasing, and we're talking about x values here, decreasing from negative infinity up to 0, and then the graph is increasing from 0 to 2, and then it looks like the graph is decreasing from 2 out to positive infinity. Alright, well, let's get busy with the math. Alright, so that function, once again, was, we'll call it f of x. Boy, f is overrated, I guess. I need to try something else. We have 3x squared minus x cubed. And so we're going to take the derivative, because the goal here is to find that critical numbers, and that's going to be a 6x minus 3x squared, and we're going to factor out a 3x. We always try to factor things out here, and that's going to leave us with 2 minus x, setting it equal to 0, and then looking at the solutions to this equation. Well, it looks like our critical numbers are going to be 0 and 2. So the critical numbers is 0 and 2. So the next thing we want to do here is try to, I'm going to attempt to draw a horizontal line. Okay, I'm going to plot my critical numbers. I'm going to put 0 here, and then I'm going to put 2 here. And then the next order of business, we got some test points. Negative 1's a test point, we'll say, and 1 is another test point, and we got to pick another one out here, and we're going to pick 3. And so we're going to take our test points, we're going to plug them into our derivative, and I prefer plugging them into the factored derivative here. And all we want to do is determine if the number is going to be positive or negative. Okay. All right. So let's do that. We got f prime. I'm going to plug negative 1 in, and I'm going to plug it into this. So this is going to be negative 3, plugging negative 1 in over here. That's going to make that a 2 plus 1, and so you're going to end up with a negative times a positive, and so that's going to end up becoming a negative number. I don't care what the number is, just whether it's negative or positive. And then we got another test point we got to try. We're going to do 1 here, plug 1 in, so 3 times 1 is 3, 2 minus 1 is 1, and so we get a positive and a positive, so that's going to be a positive number. And whoops, something I forgot to do, put a minus sign here saying that it's decreasing, and then a positive saying the function is increasing. And then now we want to plug a 3 in. So f prime of 3, right, so 2 minus 3 is going to be a negative 1, and 3 times 3 is 9, so we're going to have a positive times a negative, and that's going to be a negative, right? That's going to be a negative number. So we're going to say negative here, and that means that the graph is decreasing. So decreasing, increasing, decreasing, it looks like we're going to have a minimum around here at x equals 0, and then we're going to have a relative max at x equals 2, as you can see here. Alright, and so okay, so I'm going to say the minimum at 0 comma